Hey advanced TwinCAT users! In this part of the tutorial, we will look into ADS, which is short for Automation Device Specification. This is Beckhoffs interface for communication between software modules in TwinCAT based on a client and server architecture. You've already been using ADS, probably without thinking about it. Whenever we did an online login to read and write variables, ADS is used in the background for the communication from the XAE to the XAR. ADS is also used internally in TwinCAT for communication between different TwinCAT modules, so it's also been used just by running the TwinCAT scheduler. In this episode, we will look a little bit into the theory of ADS and look at what we can use it for. This episode is going to be a little special in the sense that we will use other programming languages than structured text, as we will talk with a TwinCAT 3 runtime using ADS from different environments by using ADS client libraries. We're even going to go so far as to download the source code for the ADS client libraries from Beckhoff's website and compile that source code into a library on a Linux machine. In other words, lots of fun ahead. Let's get started. Whenever we want to communicate with a TwinCAT system, we can use the Beckhoff ADS communication protocol. Whenever you use the XAE to communicate with a target device to, for example, read the variables through the online view, ADS is used. Other examples of where ADS can be used is in a Raspberry Pi communicating with a TwinCAT runtime. There are libraries and runtime components to use ADS at basically any possible device. It can even be used to exchange data between two TwinCAT runtimes. ADS is a server client-based protocol, so a connection is always initiated from the client to the server. It's both cyclic and event-based, so it's possible to both cyclically poll a variable as well as create a subscription for when something has changed. ADS uses TCP port 8016 and 48898 for communication and UDP port 48899 for broadcast search of devices. This means that these ports have to be taken into consideration of your firewall rules if you want to use ADS. You have so far been using ADS without thinking about it, as it's been part of the XAE environment. We have, for example, used this to access PLC variables in our programs. When doing this, the data has gone through what's called the ADS message router. It's in the message router that we can define communication channels to different TwinCAT devices. It's here that we had to add routes when we had to add a way to communicate with the real PLC in part 10 of this tutorial when we were using a real PLC. But it's not only the PLC part of the TwinCAT runtime that is accessible through ADS. Many other services, such as the motion and I/O part of TwinCAT, is also accessible through ADS. In the same way, we can have many other clients connected to the same ADS services at the same time, such as an HMI or operator panel. Through ADS, it's not only possible to communicate with the local TwinCAT runtime, but also possible to talk to different ADS services on other TwinCAT devices. Note that a message router is not strictly required on the client side when communicating with a TwinCAT device, as we will discuss and see in the practical part. All the various services running in TwinCAT are using ADS to communicate with the outside world and between each other. This includes, but is not limited to, motion control, the Opus UI server, the FTP server, Vision, HMI, the development environment, analytics, C++, and many more. I like to think of ADS like the web between all of the different services and functions of TwinCAT. When talking about ADS, you will eventually come across the AMS-NET ID. The AMS-NET ID is the address of the local computer in the TwinCAT network. It consists of 6 octets and it must be unique for all communication partners. The first 4 octets are freely selectable, while the last 2 represent devices on the local machine. When you install the TwinCAT XAR and ADS, the installation by default generates an AMSNet ID from the IP address of the system. Note that the AMSNet ID, though similar to an IP address, is not the same thing as an IP address and is not related to the IP address of the system. Because of the fact that the AMSNet ID is not the same as the IP address of the system, it can be changed at any time. To do this, go to the TwinCAT icon in your taskbar, change AMSNet ID and enter the new AMSNet ID. Within each system that has an AMSNet ID, each service is running in its own port. Think of it in the same way as TCP/IP works, where the IP address defines the host and the port defines the application, but instead here the AMSNet ID defines the TwinCAT host and the port defines the service running in TwinCAT. There are various services available. One example is the different PLC applications running. We've so far only had one PLC application running in our example programs, and this application is available on port 851. Another port is 300, which will give us access to the IO tree, so for example all the information available for an ETCAT master and its slaves. Additionally, there are many more services available, each one through its own port. Before looking into how we can set up a client-server connection with ADS, it's good to understand what actually goes on the wire. For this we need to look at the layout of an AMS packet. First we have the AMS TCP header, which doesn't contain anything else than the length of the AMS header and the ADS data, both shown under the AMS TCP header. Next we have the AMS header, which contains a couple of fields. The first four fields are the target and source AMSNet ID and port, so that we can know to who the packet is sent and who sent it in case we want to send a response. The state flags are for example used to indicate whether this packet is a request or a response for an ADS command. The command identity specifies what type of command we want to do. There are various commands that can be used, and the ADS data, the field under the AMS header, will be different depending on what we want to do. For example, we use a different command depending on whether we want to read or write a variable in a system. If we, for example, decide to do an ADS read, the ADS data would consist of an index group, an index offset, and the length of the data that should be read. We will get back into what the index group and index offset is. The response in turn for this ADS read command would include a result, which is an ADS error number, the length of the data that is returned, and the actual data that is returned. Now enough talk, let's dive into some practice. Hello everyone, so now we will do a little bit of practice with ADS, and we will do this by creating two programs. We will create one program using the .NET environment, using the C# language. So this is going to be based entirely in Windows, and another one that's running in a Linux environment where we will be using the ADS open source library and use C++ as language for development. And I just wanted to start by showing you this website for ADS at the Beckhoff Infosys. First of all, you can read a lot about the basics about ADS, so more or less the stuff that you already learned from the presentations, but also a little bit of other things. And the important thing here to note is that we have language bindings for many different languages for using ADS. So what you get together with the TwinCAT installations is some libraries and pre-compiled libraries for you to use with different languages. So for example here, Beckhoff provides a DLL to use in Windows for if you want to use C++. So you can read here, for example, how do I integrate it, and it includes headers and everything for C++, and you have documentation here, what library you have to include for your compilation for this to work. And you have other things here, like for example a DLL for using it with Java.
and for .NET that we will soon look into. It should also be noted that there are language bindings for other languages, not just these. So they are not from Beckhoff then, they are third party, and they're usually just wrappers around any of these others libraries that Beckhoff has developed. One of this is open source library that's called PyADS if you want to use ADS. I've personally used this. I think it's really great. It's a wrapper library around the C API from Beckhoff, so it's very, very high performance. And yeah, so you basically have bindings for any language that you might come across. There's also, if you want to use Node.js for JavaScript and others. So I never had a problem to not find a language binding for any programming language. However, today we're going to do .NET, C#, and C++ in Linux. And I'm going to start with the .NET environment. But before that, I want to show you that I've created an extremely simple PLC program, which is what we're going to use to read and write variables to. So we need to have a PLC program, and because what I'm going to show you is how you read a variable and how you write to a variable. The only thing that this program does is that it has an integer to read that just increments by 1, so it's just a counter, and then an integer to write. So we're going to write to this integer and just do an online view to see that this number is changing. So if I do an online login now, then you can see that this value is being incremented, while this is just standing still, because we're going to change this by writing to it. A very simple program. We're going to start with doing an ADS client using .NET and C#. For this, I've installed Visual Studio 2022. You can use whatever Visual Studio you want. The reason I chose this guy is because I'm going to create a .NET 6 project. So we're going to create a new project. We will just create a simple console app with the C# language. The nice thing here is with .NET 6 is that you have cross-platform compatibility. So you can use this program in a Linux, Mac OS, or Windows environment, which is the nice thing with this new .NET framework. Well, it's not called .NET framework yet. The naming is super confusing, but .NET 6. And we can call it ADS client. Next. And yeah, I don't like to use this top level statements. This is not so important. And it's going to be a .NET 6 project. And soon you're going to see how extremely easy it is to integrate ADS to your software. Because there's really a lot of documentation and just a lot of examples. And I should tell you now that already that most of the examples from the Beckhoff website are for .NET C#. I mean, Beckhoff and TwinCAT and everything is a Windows platform, and for a historical reason, .NET and C# has been mostly what you've been using if you worked on a Windows platform, at least the last 20 years. So it's very, very heavy with the examples on .NET C#. However, as you will see, it's not bound to that. You can use Java or C++ or Python or any other language as well. It's just that if you start with this, I would really highly advise you to start with using .NET and C# simply because there's most examples with this environment. The first thing we're going to do is to include a reference to the ADS library itself so that we can use ADS to communicate with our PLC. And another thing I forgot to mention here is actually that, so we're running this in the TwinCAT in our virtual machine. So we have TwinCAT running our virtual machine, and we will also run the ADS client in the same machine. So it's not going to run from a separate machine to communicate. We're going to do this later actually when we run the C++ example, because this is going to be executed in a separate virtual machine. But right now we run everything locally. So first of all, let's add the reference. For this we use NuGet. NuGet is a package management system for the mostly the .NET environment, and Beckhoff have prepared NuGet packages to use for ADS. So you go here, and then you browse and you search for beckhoff.ads. Then you have the Beckhoff TwinCAT ADS, not the server, just select the TwinCAT ADS. Select the project to include it in. So what we're going to do now is that it's going to reference the ADS library so that we can use it in our program and install it. Just select the latest stable release. So this is very convenient because it downloads everything for you and installs it, and yeah, then it's just ready to be used. And now we're gonna write, first we can just compile this project and make sure that it can be run. So I will build. Oh, it's building right now. I pressed Ctrl-Shift-B, by the way, as a shortcut for anyone that's not used to writing software for .NET. And actually one question I got quite recently is, why don't you just use the TCXA shell to write the C# software? The simple reason is that the TCXA shell that you get with TwinCAT, that's only for PLC software. It's only the Beckhoff kind of just stripped down all the stuff from Visual Studio and just left TwinCAT stuff in there. So we need a full, so to speak, Visual Studio installation just to get all the .NET stuff in as well. So let's run the software. It's ADS client. It's not gonna do anything now. It's just a hello world example. And we have to add, we have the reference here in packages to ADS that we just referenced. And now we can go to the documentation and get an example to read a variable. So I'm gonna start by simply reading this variable. That's what we're gonna start with. And for this, we go to ADS.NET version 6, because we downloaded the version 6 type of libraries. I would strongly encourage you to use version .6 or newer. For this, there's no reason to use the version .4. This one is much, it's easier to use, but it's also much better performance. You can read the version history and everything if that's interesting for you, but just use this guy or a newer version if it's available when you watch this video. Then we can go to concepts. And here you have a couple of examples of how you can use this library. So again, you could of course look into the API to see how all of this is working, but you know, it's quite a lot of stuff and not exactly a good starting point if you're just starting to use this library. So I would go to concepts, and here we have, for example, how do I read and write by index group and index offset. So as you saw in the presentation previously, we could to read a variable, you send this command read, and then you have an index group and index offset. And yeah, so if we look here, for example, then we have a value to read, and then if we go down here, we have client.read. So we create a client, which is an ADS client. We connect it to the local host, the local AMS net ID, which we're going to do here, because again, we run this in a virtual machine, port 851. That was the first PLC program, right? So when you create a PLC project, this guy, the first one that's going to be created is going to be 851. If you create another PLC project here, it's going to be 852 and etc. So this is the first PLC project, and then you read from this index group 4020 and 00. And what I want to say here is that everyone I talk up with is always like, yeah, but what's this 4020 and what is this index offset? Because what you're actually doing here is that you read the index group and then an index offset, and then you store the data in a byte array, and this is quite hard to read. And if you actually go to the documentation for ADS, then you get, if you look for 4020, yeah, then you have the different PLC services and where they are available. And 4020 is the one where you have the PLC memory range, so basically the PLC variables. And you could use this API and read variables this way. The problem is that there's many problems, but one of the problems is, for example, that if you move variables around, then this index offset is also going to be moved around. You know, a variable that was in position 0 is going to be at another position if you recompile and you move the variables around. So I wanted to show you that it's possible to do it this way, but it's not going to be the way we're going to do it, and it's not going to be the way I would recommend you to do it. It's going to work this way in the background, but there's a much better way to read and write variables, and that is to use access data via symbolic path. So here instead, what you do is that you still connect to the client, and then you access it by the name of the variable. So main.encounter, or in our case, it's main.nint to read. And that's of course much easier, because then as long as you keep the path is the same to the variable, it doesn't matter where the variable is in the memory. The ADS will take care of that for you. So this is what we're gonna do. let's simply read this. Let's simply read the variable. So the only thing we have to do is copy paste code. And this is something for everyone that's not doing PLC code, but for anyone that's doing any other programming language, C#, C++, Java, there's just a million of stuff from Stack Overflow that you can normally copy. Now we're doing the same, but from the Beckhoff website. So let's copy this guy. And now integrated development environment doesn't know what an ADS client is because we haven't put in the appropriate using. Oh, it actually did it automatically here as we spoke. So this guy should, is a name, but is like a type. Ah, I see the problem. The problem is that this class is in TwinCAT ADS, but we happen to name the namespace the same. That was a little clumsy. Let's just rename the namespace to ADS client example. So that should look better now. And the ID automatically added the correct namespace for us. Now the thing is that we're just gonna read for now. We will write. We can do a write when we do the C++ example. Right? Let's just focus on reading the value. And we're gonna connect to the local. We want to connect to port 851. We don't want to write any value, but we want to read a value. And the value we're gonna read is not an unsigned integer because we declared it as a integer. So let's just get rid of this. Skip it at int, client, read the value, and now instead of main.encounter, it's gonna be main.n_int to read, and int to read. And if you want to, you can at any point look into the documentation here. This is super convenient, and you can see one of the variants is to use a string name where the name refers to the path of the variable, and then the data type that you want to read, which is an integer. And there's some overloads, so there's other ways to read the value. So it's a very, very easy. Now we compile it. Actually, maybe we should print it as well. So console write line. The value is, and then we can just value to read to string maybe. Okay, successful. Let's run it. Yeah, the value is 17,543. That was probably right when we were running this. Let's run this in the background. 18,000, yeah. So again, if you want to look into the API, you can go and look, for example, here we're using the client to read the value. So the client is the ADS client. You can at any point in time go to the API. You can look at the ADS client. You can look at all the methods. So one of them was the read value, and the one we used is this one, reads the value of a symbol and returns the value as object. So this is of course a very nice one, and it's all available here. Another thing I should mention is that the one thing you might think about now is, yeah, but how come that this application has access to the PLC? The simple reason is right now we're only running it locally. If you would connect to anything else here outside of this virtual machine, so if you had a real PLC outside, then you would need to create an AMS route. So you would have to go here and edit routes, and you would have to create a physical route. So here I have actually a physical PLC here behind me, and that would have to exist before that. And then you would only reference the AMSnet ID here, because it has to be unique in your control network, and you make sure it has access to it by, you know, creating the route, just like we did when we were doing the part about I/O, when you have to enter the IP address of the PLC and you enter the username and password and everything so that you have the credentials to access the PLC. However, as long as it's only localhost, we can do this without entering the credentials, because we are on the local machine and already have all the access that we need. I would highly encourage you, this was a very simple example, so I would highly encourage you to look into the other examples here. So you have, if you look here, you have other things that are very interesting. Look at this ADS notifications, and yeah, there's just, I always start with examples to kind of understand how something works, and I think Beckhoff have done quite a good job here with providing a wide variety of examples for you to use. So far we've only been running everything off a Windows platform, but I thought we would have a little bit more fun today and run a little bit of ADS from a Linux platform using C++. And here to the left we have our standard virtual machine that we have always been using, and it's running the TwinCAT software. And here to the right we instead have another virtual machine, but that's running Linux. In this case it's Debian. You can use any other Linux of your choice. And I'm gonna use Visual Studio Code for the development environment, simply because it's my favorite one. I think actually it's the most popular one right now. And I've installed all the C++ extensions and everything, and we're gonna compile the ADS library from source, because what Beckhoff provides is an open source library for the ADS client. So if you go to GitHub and you go to Beckhoff, then you have ADS here. And we're gonna clone this repository and compile it and use ADS from the source code. And you can see here that it's quite well documented actually. They've quite regularly update this documentation and test it with newer compilers. And this one has some examples included that we're going to use to communicate with our PLC. So I thought we'd simply together here, right and now, go through this and follow the instructions to compile this and use this. And we'll simply start with cloning this repository. And for that we need a terminal. Oops. No, we don't have a terminal, so. Oops. Oh, there we go. And let's see here, we'll put it into documents. We'll clone this repository. And now that we've already learned how Git works, we know this already. So again, here in Linux, we're not going to use a graphical user interface to clone it like we did in the version control video that I made. Here we're going to use the command line instead. So paste git clone. It's going to be cloning here. We have ADS there, and we're going to compile this and use the project examples that they have here. I have personally not used these examples yet, so it's gonna be a lesson for me as well. But that's what a live coding session is all about. Change into root of the cloned repository. We've done this. Configure Meson to build. Meson, I have no idea, but this is probably some sort of build tool. The Meson build system, yeah. Interesting. There's so many build systems now that I lost count and track of it. It's almost as popular as a new build system is almost as popular as a new JavaScript framework. I'm getting old that I don't follow along, but it just says Meson build, so let's do that. We can see it. What does it do? Okay, it found my compiler, GCC, the linker, everything, what platform I'm on, and it found my okay, so it's using Ninja as well. That's another build tool. Let's see. Okay, let Ninja build the library. Okay, so Meson. So let's just do that. Let's build the library, because we have to build it, because this is going to produce the library that we will later use in our C++ code. Now it's compiling everything. There's quite a lot of stuff. Perfect. So now we got the libraries, and now we just have to use them. And I thought we'll simply use the examples to run the code. And here it says prepare your target to run the example. We're not going to use the PLC test project that's included in this library. in this repository, because if you go here to example, then you have a PLC, not example, where is it? PLC test project. This is a full PLC test project. We're not going to use that. We're going to use our test project that we already have running here and use this guy instead. And oops, what am I doing? I want to go down. And yeah, we have to authorize our ADS client to accept a connection. So that's the thing. On this end, we don't have a AMS router, right? So on the Linux side, there's no TwinCAT icon or anything that you can go to and you know, fiddle around with AMS routes and add a route from here to the Windows machine. If this was a Windows machine, that would be no problem. Then we would simply let this client, so this virtual machine, have access to this machine by adding an AMS route to this. So again, this is, you have to remember that this is now the PLC. This is just a client. It could be, you know, anything, anywhere. On Windows, this would be no problem because we would just make a link from this guy to this PLC, which you would most likely have anyway, because you would have to create an AMS route to upload PLC code on the PLC. But we don't have that on Linux. So what it says here is that we have to do it in the other direction. So we have to tell the PLC, so this virtual machine, that this machine has access to this, which we can do in this reverse way. So it actually says, yeah, let's just follow the instructions. It says authorize your ADS client for the TwinCAT target by adding an AMS route. So let's do that. Router, edit routes, add. This is a tiny screen, or it's not a tiny screen, it's just too much stuff on the screen at the same time. Right now it would be nice to have 2 monitors, because you actually get twice as effective with 2 monitors, as everyone knows. And maybe if I had 2 brains, it would be more efficient. So let's add an AMS route. It says call it my ADS client. You can of course obviously call this anything else you want. You need the net ID of your ADS client. This is derived from the IP address. Okay, so if in this example, if the IP address is this, then the AMS net ID is gonna be the IP address of the client plus 2, 1, and 1. So we have to check what the IP address is on this end. So our IP address is 192. So I assume that the client side, so when we connect with the client, then the client will generate the AMS net ID based on this IP address. That's what I assume. That's how I assume the library works. So we do it like this, 192, 168, 1.1. Then the IP address is obviously gonna be 192, 168, 217. And what does it say more? Transport type TCP IP. Yes, we're gonna use TCP IP. Remote route has to be server, so we have to change this one to non-server. And unidirectional and secure ID is false, which I think, yeah, this looks right. Actually, I just remember we also have to open the firewall for ADS, which might already have been done on this machine. We can go to firewall. So again, we have to imagine that this is the PLC now. Advanced settings, inbound rules, and we actually have rules for ADS already. So ADS here, that's probably the TCP one. Allow port 48,898, which is the port that we saw in the presentation that is used for communication with ADS. So that's already open. So the firewall is set for this, and we add route. Not secure ADS, okay. I guess that's it. Refresh, yeah, there we go. So this PLC now kind of allows this Linux client to connect to it, which means that it doesn't require this AMS router over here for the client, which is convenient. Now we've done this. prepare. Okay, so we have example CPP. I'm just gonna check quickly here. TwinCAT 2 doesn't apply to us. Windows C doesn't apply to us. So prepare your client to run the example CPP. And for this, we're gonna open this example using Visual Studio Code. Open folder, documents, ADS. We can just open this whole guy, open. Oh, that's really nice. It detected CMake. And so let's now do some changes. It actually says here that you have to do some changes to the application so it matches your environment, because obviously this was written for the example project that Beckhoff has. We will not use it. We also have different IP addresses than this. So this client needs to know which PLC it should connect to. And example CPP it says. So we go to example CPP. Here we have the code. And let's see, where's the main? Here's the main. So here is the entry point for the application. It's gonna run the run example, provides the standard C out. Okay, run example runs some different examples. Sounds reasonable. Notification example, we only wanna do a write. So we have a read-write example, not a write example, but a read-write. So we can probably get rid of the reading and just use write. So we can already now get rid of all this other stuff that we don't want to do. Actually, before we do this, let me just compile this and see that it builds. So I'm going to do what they say here. Configure Mason to build example into builder. Let's do that. So let's Mason example build example. Let's see what happens. I love it when it works, because actually, to be honest, with Linux, you know, it's usually more work. It usually never works on the first try. And then we build it, paste. Ah, okay, wait. Let me just get back on this stuff, because maybe I screwed something up. So let us just, yeah, okay, so it worked. So for some reason, the stuff I commented out made the project not compile anymore. Okay, but then we know everything is compiling, and hopefully we can run the example now. It's probably not going to work because we haven't changed the IP address or anything, the AMSNet ID, so it's going to point to a PLC that doesn't exist. But we can still try it because it's fun. And I like to see stuff fail as well. Yeah, ADS error, not a big exception. ADS operation failed with error code 6, which probably means that it can't find the target or something. So hit enter to continue. So let's first read what it says. Set remote net ID to the TwinCAT target, so this PLC. So the PLC has a net ID of, so change AMS net ID, then we can see it. It's this guy, and it's 192, 168, 4, 200, 211. And then we probably have to set the IP address of the PLC here, right? It's optional. No, not optional. Set remote IP version 4 to the IP address. So we have to check the IP address of this machine. And that is 192, 168, 4, 220. Right? Yeah. Ah, looks reasonable as well, because the AMSNet ID is the IP address plus 1.1. So this should now build. Let's rebuild it and run it. Okay. So it seems to be working. I'm not sure exactly what that beef. I'm not exactly sure what this example does, but we're gonna tune it so it does the stuff we want it to do. And this is generally what I recommend. Look at examples, have that as a starting point, and tune it to your needs. And our need is that we want to write this and into write to something else, number 42 or something. So let's, again, I'm gonna see why couldn't I just remove this? What does the compiler say? Read-write example, because that's probably what we want. If I go to read-write example, this seems to be what we want. We're gonna have to adapt it, of course, because the variable we want to write to is n into write and not this by byte. But let's compile this and see why it doesn't. Okay, it's just warnings. These are warnings. It just says that, hey, you have this method that you're not using. It's defined, declared, but you're not using it. You see, it says defined but not used. And that's just a warning. The compiler uses a flag that says that to treat warnings as errors, and we have to get rid of that. To do that, we have to remove a flag. I would say it's probably, I think it's this guy. Let's just check. GCC, yeah, I think it's this. Make all warnings into errors, v-error. That's the guy. That's the bad guy that we want to get rid of in this case, because we don't care about this, because we deliberately don't want to use these methods. We only want to use one of these. So we have to figure out how we get rid of this, because it's using, and to do that, we have to look into the make file of this example, which we used Meson. Is it called Meson? Meson? I have no idea how you pronounce it. I didn't know it existed until right now. It's probably this guy. Maybe it's the make file. No. Oh, let's look. How does this work? So v-error equals true, right? We want to get rid of that because we don't want warnings to be treated like errors. So let's write this guy and rebuild. Oh yeah, no, I probably have to run this command now. Exactly, Meson, because we changed the Meson file. I hope I'm not embarrassing myself now by saying Meson. I don't know if it's pronounced Meson. But if it's Meson, then if it's not Meson and I say it wrong, it's just going to have to be a Swedish version of the pronunciation. Directory configured, but that's not. Just run your build command. If build failures, okay, so maybe I can run it now. No. So why doesn't it rebuild it? If build failures persist, which we have, run Meson setup wipe to rebuild from scratch. That sounds good. And now let's run the Ninja. Now it worked. Okay, so we got rid of the compile flag that we don't want, because we don't want the compiler to care about warnings, just treat them as warnings and not as errors. And now we can probably run the example, though the, sorry. There we go. Yeah, we still get an ADS error because we have the wrong variables here, because this variable doesn't exist. So now what we have to do is, what this does is that it first prints the, I guess it prints the function name. What's this? This is, function is a pre-standard extension that some C compilers support. So what does this do? I love Stack Overflow. How I would never be able to work if Stack Overflow didn't exist. Actually, I could work before Stack Overflow. I did that, but it just makes life much easier. I wish more people from the PLC community could contribute to Stack Overflow or similar websites. What's the difference? Function is a simplicity declared identifier that, okay, it just prints the function name for us. That's neat. And then let's change the variable names. So what we want to do here is not use, we want to write, so int to write. I don't know why it's twice. One is probably reading and one is probably writing, so that's good. And it wants us to write, let's skip hex and just write 42 here. And we don't want an unsigned int. This 8, we want to have a signed integer 16. Exactly, this is from the standard. What we want to write instead is, so declare is an integer 16t to match the data type on the PLC side. And we want wrote 42 to, and read, here's the same, int 16 back. Okay, so what actually happens here, this is really nice, because the way this one works is that you can simply write the variable by assigning it a value. So they've overloaded this, the assign operator probably, which is very, very convenient. So as you can see here, it's extremely easy. As long as you have a connection, as you have an ADS connection, then writing and reading variables is extremely easy using the C++ library. So we're gonna do the same here. We're gonna, okay, now it wants to write another variable, so let's just write 43. Well, we can skip this, we don't need it. We just wanna write 42 and see that we get 42 in this end. Yeah, I really like this implementation. So all we have to do now is to compile and run and see if it works. Wrote, oh yeah, it worked, amazing. Wrote 42 to main and int write and read 42 back. So we did both a read and write. Write and read. Did we actually do a read? Yeah, because validation is pointing to n into write. Yeah, I really like this library. It's very easy to use. So this was just a very, very tiny taste of what's possible with using ADS. We just did some very simple examples by reading and writing variables. You can do much, much more using ADS. But the point here, I guess, and what I want you to take with you home is that this is a very open system. You can do a lot of stuff, and you can not just use the client, to read and write variables. You can do a lot of other stuff, but you have language binders for many different languages, and none of this requires any particular licenses. All of this is free software. You don't have to pay anything for using an ADS client. You only not have access to all the PLC variables, but you also have access to, if you want to have access to the IO or some other stuff, if you want to, we haven't done any scope here, for example, but you could have access to the scope data as well. And it's a very open platform, and you can play around with it. I mean, we did a very quick test here now, but you could play around with this quite a lot. And I mean, for me, this is just the joy of everything. I love to learn new stuff, and for me, it has to be easy to learn. This is always what I try to optimize for the learning process. This is what the aim for us as engineers should be, to just learn as easy and quickly as possible. And I feel with ADS I actually have access to everything and even a little bit more. And I hope you got the same feeling as me, and that you can take this with you home and play around with it a little bit more after this tutorial.
Thanks to ADS, Beckhoff are unlocking lots of possibilities to talk to and interact with a Beckhoff PLC and TwinCAT runtime. ADS is just another thing that clearly shows how open the TwinCAT platform is. In the next part of this tutorial, we will be looking at the TwinCAT automation interface, which we can use if we want to automate TwinCAT tasks. Thank you very much for listening, and see you in the next part.